In chemistry, isomers are molecules with the same molecular formula but different chemical structures. That is, isomers contain the same number of atoms of each element, but have different arrangements of their atoms in space. Isomers do not necessarily share similar properties, unless they also have the same functional groups. There are many different classes of isomers, like positional isomers, cis-trans isomers and enantiomers, etc. There are two main forms of isomerism, structural isomerism and stereoisomerism. Structural isomers. In structural isomers, sometimes referred to as constitutional isomers, the atoms and functional groups are joined together in different ways. Structural isomers have different IUPAC names and may or may not belong to the same functional group. This group includes chain isomerism, whereby hydrocarbon chains have variable amounts of branching. Position isomerism, which deals with the position of a functional group on a chain. And functional group isomerism, in which one functional group is split up into different ones. For example, two position isomers would be 2-fluoropropane and 1-fluoropropane, illustrated on the left side of the diagram above. In skeletal isomers, the main carbon chain is different between the two isomers. This type of isomerism is most identifiable in secondary and tertiary alcohol isomers. Tautomers are structural isomers of the same chemical substance that spontaneously interconvert with each other, even when pure. They have different chemical properties and, as a consequence, distinct reactions characteristic to each form are observed. If the interconversion reaction is fast enough, tautomers cannot be isolated from each other. An example is when they differ by the position of a proton, such as in keto-enol tautomerism, where the proton is alternately on the carbon or oxygen. Example, propanols and methoxyethane. A simple example of isomerism is given by propanol. It has the formula C3H8O and occurs as two isomers, propan-1-ol and propan-2-ol. Note that the position of the oxygen atom differs between the two. It is attached to an end carbon in the first isomer, and to the center carbon in the second. There is, however, another isomer of C3H8O that has significantly different properties, methoxyethane. Unlike the isomers of propanol, methoxyethane has an oxygen connected to two carbons rather than to one carbon and one hydrogen. This makes it an ether, not an alcohol, as it lacks a hydroxyl group, and has chemical properties more similar to other ethers than to either of the above alcohol isomers. Example, alen and propyne. Alen and propyne are examples of isomers containing different bond types. Alen contains two double bonds, whereas propyne contains one triple bond. Stereoisomers. In stereoisomers the bond structure is the same, but the geometrical positioning of atoms and functional groups in space differs. This class includes enantiomers, which are non-superimposable mirror images of each other, and diastereomers, which are not. Enantiomers always contain chiral centers and diastereomers often do, but there are some diastereomers that neither are chiral nor contain chiral centers. Another type of isomer, conformational isomers, may be rotamers, diastereomers, or enantiomers depending on the exact compound. For example, auto-position-locked biphenyl systems have enantiomers. Isomers, which have restricted rotation within the molecule, to be specific isomers containing a double bond, are configurational isomers. They are classified as diastereomers, whether or not they contain any chiral centers. EZ notation depicts absolute stereochemistry, which is an unambiguous descriptor based on CIP priorities. Cis-trans isomers are used to describe any molecules with restricted rotation in the molecule. However, these descriptors describe relative stereochemistry only based on group bulkiness or principal carbon chain, so can be ambiguous. This is especially problematic for double bonds that have more than two substituents. An obsolete term for cis-trans isomerism is geometric isomerism. For alkanes with more than two substituents, EZ notation is used instead of cis and trans. If possible, E and Z is also preferred in compounds with two substituents. In octahedral coordination compounds, ferrilo-uromeridional isomerism occurs. The isomers can be Fa or Mer. Note that, Although conformers can be referred to as stereoisomers, they are not stable isomers, since bonds in conformers can easily rotate, thus converting one conformer to another, which can be either diastereomeric or enantiomeric to the original one. While structural isomers typically have different chemical properties, stereoisomers behave identically in most chemical reactions, except in their reaction with other stereoisomers. Enzymes, however, can distinguish between different enantiomers of a compound, and organisms often prefer one isomer over the other. Some stereoisomers also differ in the way they rotate polarized light. Isomerization. Isomerization is the process by which one molecule is transformed into another molecule that has exactly the same atoms, but the atoms are rearranged. In some molecules and under some conditions, isomerization occurs spontaneously. Many isomers are equal or roughly equal in bond energy, and so exist in roughly equal amounts, provided that they can interconvert relatively freely, that is, the energy barrier between the two isomers is not too high. When the isomerization occurs intramolecularly, it is considered a rearrangement reaction. An example of an organometallic isomerization is the production of decaffeinylferrocene, I5C5 2Fe from its linkage isomer. Synthesis of fumaric acid. Industrial synthesis of fumaric acid proceeds via the cis-trans isomerization of maleic acid. Medicinal chemistry. Examples of isomers having different medical properties can be easily found. For example, in the placement of methyl groups. In substituted xanthines, theobromine, found in chocolate, is a vasodilator with some effects in common with caffeine. But, if one of the two methyl groups is moved to a different position on the two-ring core, the isomer is theophylline, which has a variety of effects, including bronchodilation and anti-inflammatory action. Another example of this occurs in the phenethylamine-based stimulant drugs. Phentermine is a non-chiral compound with a weaker effect than that of amphetamine. It is used as an appetite-reducing medication and has mild or no stimulant properties. However, a different atomic arrangement gives dextromethamphetamine, which is a stronger stimulant than amphetamine. In medicinal chemistry and biochemistry, enantiomers are a special concern because they may possess quite different biological activity. Many preparative procedures afford a mixture of equal amounts of both enantiomeric forms. In some cases, the enantiomers are separated by chromatography using chiral stationary phases. They may also be separated through the formation of diastereomeric salts. In other cases, enantioselective synthesis have been developed. History. Isomerism was first noticed in 1827, when Friedrich Weyher prepared silver cyanate and noted that, although its elemental composition was identical to silver fulminate, its properties were quite different. This finding challenged the prevailing chemical understanding of the time, which held that chemical compounds could be different only when they had different elemental compositions. After additional discoveries of the same sort were made, such as Weyer's 1828 discovery that urea has the same atomic composition as the chemically distinct ammonium cyanate, Jar paragraph N.S. Jacob Berzelius introduced the term isomerism in 1830 to describe the phenomenon. In 1848, Louis Pasteur separated tiny crystals of tartaric acid into their two mirror image forms. The individual molecules of each were the left and right optical stereoisomers, solutions of which rotate the plane of polarized light to the same degree but in opposite directions. Other types of isomerism exist outside this scope. In general, topological isomers called topoisomers are large molecules that wind about and form different shaped knots or loops. Molecules with topoisomers include catenanes and DNA. Topoisomerase enzymes cannot DNA and thus change its topology. There are also isotopomers or isotopic isomers that have the same numbers of each type of isotopic substitution but in chemically different positions. In nuclear physics, nuclear isomers are excited states of atomic nuclei. Spin isomers have differing distributions of spin among their constituent atoms. See also, nuclear isomer, chirality, structural isomerism, cis-trans isomerism, cyclohexane conformation, electromerism, ligand isomerism. References External links.